This is pump package number 6 in a series of pumps. This is the electrical cover, and it's small and compact and has plenty of features in it, but it's not completely feature rich to the point it doesn't have any network access, doesn't have any alarm configuration to send it through a network. So, but it does have a lot of features to it. It is driven by a DC motor down here, and I think you can see it now. You can't, but it is down below the electrical panel. We have quite a bit of piping here. This is the input supply here. This is the output over here, high pressure. Right now it's running at about 200 psi. Well, it's not running right now, but when I turn it on, it'll be running at 200 psi. So we've got a pressure, a filter here, screen 80 mesh filter, water regulating valve, comes up to an input solenoid valve, comes over here, and then actually goes down into the input of the pump assembly itself. This is part of the pump that you can see down here. And it goes through there and it pumps out high pressure in the middle over here. It comes out this hose, high pressure hose here. There's another way to get at it, high pressure over on this side also. And then back here, we'll see it a little bit later, there is a solenoid valve that's actually a dump valve. When the system shuts off, this opens up for less than a second, right around a second, a little bit less. Dumps high pressure solution, high pressure water back here, back into the low pressure side, but it hits this tank here, and this is an accumulator bladder tank that actually cushions the high pressure water coming back. And what that does is that when it does shut off, we relieve the high pressure back into the low pressure, cushion it by this black tank here, and it actually takes the high pressure and goes to 0 psi right away. So you don't have any spitting or sputtering of the nozzles itself. The nozzles are spraying, and then they shut off. So that's the idea behind that. Trying to shut this thing off. So all the controls, the solenoid valves, and there's a low pressure switch out here also, they're run by 24 volts DC. So anything that's out here in the open is 24 volts DC. This is the power cord coming in. This is 120 volts, just a standard plug on this guy. And but then the controls itself, we've got quite a few controls in here, and you can see the top of them. We'll give you a little bit better picture here shortly, but there's a DC power supply in there, and there's a few timers and a circuit breaker, and then back on this back wall here is the DC variable voltage regulator to go to the DC motor, 0 to 90 volts DC to regulate the speed of the motor. And then we also have a potentiometer back here that actually can regulate the speed of the motor. This pump itself actually has a pretty high capacity. It's a half a gallon a minute. And we have 2 nozzles on here. These nozzles are only probably at a 50th of a gallon a minute, these 2 nozzles put together, so a lot less capacity than the pump has itself. So that's the idea behind slowing the pump down through the DC drive to match the output of the nozzles to a degree. The nice thing about slowing a pump down is you get it to last longer. It's like the engine in a car. If you were going to run your engine in your car full blast all the time, it wouldn't last. If we can slow this pump down, it's going to last a long time. So that's the idea behind the variable frequency drive. Well, actually a DC motor, the DC output to it. Okay, here's inside what it looks like inside the control box. Here's a DC power supply, 60 watt, and that supplies the two solenoids, which are DC, and then these relays that are driven by DC. This is a DC also, but it's a DC power supply, you could say, to itself. It's separate from this one, and there's 120 volts AC coming into it, but when you vary this potentiometer over here, you actually vary it from 0 to 90 volts out DC to drive the motor. This is just 24 volts DC to supply power to these relays, and then to supply power to these solenoids in this control, in this low pressure switch right over here. It's over here. Now let's adjust that. There we go. So now you can see that the DC solenoid, a low pressure switch to prove that there's pressure water, and another DC dump valve over here. So that's what this DC power supply is for. All those three things and the relays. Now, as far as the relays itself, we've got a time delay relay here. It's kind of at an angle. I ran out of room. This is actually a short cycling loss of power type relay, where this actually times out that we have good power coming to this unit for about 4 seconds, and then it'll energize it. So that keeps it from, if we do have fluctuating power, we got brownouts or something like that, this will shut the unit down and then make sure we have stable power again before it'll start it back up. So if we get a lot of dirty power, this thing will shut off and stay off for a little while. Down here in the bottom, we've got a circuit breaker. It's 10 amp AC of 120 volts. It's the only breaker that's in there. However, we do have a fuse for the DC power supply for the motor over there. Then we've got a timer here and a timer here, and then a relay. Now this timer here is really the on-off cycling timer. It's 0 to 300 seconds or 6 minutes. Actually, it's 3 seconds to 300 seconds. So again, that's a nice short cycling prevention device in case somebody turns it all the way down to 0 and 0. At least cycle on and off every 3 seconds rather than 1 second or a half a second or something like that. So that's a nice timer. Again, cycle timer, off time, on time, delay. This timer here is actually the dump valve timer. It's a trigger timer. So when there is an off cycle, some contacts change in the timer, and then as soon as it goes into off cycle, it triggers this guy to start his timing, and it opens up this dump solenoid for 1 second and then shuts it back off again. So that's the idea behind bleeding the system down very quickly. This is the DC power DC dump valve, comes through here, up through here, and into this bladder tank into the low pressure side, and at very high pressure goes to 0 right away, and this bladder or this diaphragm tank absorbs that shock of that water, and it goes down to 0 right away. So that's well, this little cube relay down here, that's actually driven by this time delay, this cycle timer, and all that's doing is giving more contacts to operate some of the rest of this. So when the cycle timer turns on, it actually triggers this drive to start up. Just through a set of contracts, says, okay, motor, you can start up. It also sends a signal to that relay, which has 2 more contacts in it, and those contacts open and close this solenoid right here, and then they also trigger this thing when it does shut back off again. So that's the majority of the controls that are in here. Again, this is a mist pump that it can cycle on and off through these two controls, 3 to 300 seconds. Provides a dump valve, provides regulation for how much pressure you're going to have. And actually it's not regulation on so much pressure, because down here you can't see it, but there is a pressure regulator right now. It's set at 200 psi. So the motor itself is actually going a little bit faster than the 200 psi, and this pressure regulator is working, but it's just a little bit faster. So you have some bypass going on. That bypass does help give you smooth output pressure. But it lets you slow the motor down, so you can use just a couple of nozzles, or you can speed the motor up till you lose more nozzles, and then it gives you your added your slower speeds make your motor last a lot longer. That's the key behind really having this DC drive, is to match the speed of the motor to the output. You can slow it down a lot, and then the motor will last, or the pump will last a long time. Okay, I'm going to start this unit up now. You're going to see a series of lights come on. It's going to be about 3 seconds, and then you'll hear the pump start to ramp up. So here we go. We have power. And there it is. It's running. You can tell that it's not running very fast, but we are generating about 200 psi. Again, through this knob over here, I can vary the speed, but that's about all the speed that we need to supply the pressure that we need. And then these dials here, you know, I set it off. That just shut it off, although it was ready to shut off. And I'll set both of them at 3 seconds, and you can see starts up, shuts off. Starts up, shuts off. Starts up, shuts off. And we'll go out here a little further. Now you'll see when it does shut off that this output, this red light lights up, and that's actually the signal going to that dump valve that's over here. There, you just saw it. It's on for a split second, and that opens up that valve, and the discharge gauge, you can't see it, but it's over here, immediately goes to 0. And if you didn't have that dump valve in there, you would actually slowly go down, and you'd have some spittering and sputtering of the nozzles. There it goes again. You can see that this light on this thing is kind of in reverse on the relay itself. The extra contacts driving in reverse of what it needs, but there are single pole, double throw relays in there. And there it goes real quick. So that's that. I'm going to unplug it now. And the only other thing I could talk about would be wiring to a degree. But I could add that this DC regulator here for the motor does have a few potentiometers on it. It's got a maximum and a minimum potentiometer. And I'm actually using the maximum potentiometer, even though this is a potentiometer here that controls it, but I'm using this one just so it can't be ramped up real fast. I do that just to make sure somebody doesn't ramp it up real fast. If they've got a little small amount of nozzles in there, then they bypass too much water. And then there's a minimum down there that's just set at 0, so it will shut off. And then there are some other potentiometers down there. One is for how slow it ramps up and how slow it shuts back off. So that is about it. I could give a couple other views so you can see a couple things. Let's do that. I'll change the camera here. So here's a shot. You can see the DC motor down here. It's a 3rd horsepower. And it's, you know, that's the guy that's regulated off that DC voltage regulator. Pump itself here, and then a side angle of some of the fittings. This is just kind of a temporary thing here, you know, on-off valve for demonstration purposes. Here is the actual regulator itself that regulates the pressure, the bypass pressure, or the output pressure. That's got it set at 200 psi right now. This pump will go up to about 500, 600 psi. I think 600 is the max rating of the pump. Works real good at 200, but if you wanted to run it at 400 or 500 to get some good atomization, good mist out of it, you can do that. This is actually an oilless pump. It is a pump that doesn't need any oil. It actually is lubricated by the water, and the bearings themselves are ceramic type bearings. So they're lubricated by the water, and they do just a fine job without any oil. So I guess that's about it. I'll show one other angle of it so you can get an idea what it looks like from kind of like the front angle view, and we'll go from there. Okay, so you can get an idea a little bit more what the bladder tank or the accumulator looks like. There's 2 gauges on it. You can get a good look at them here. This is a input water pressure gauge, and this is a discharge gauge here. It tells you what the discharge pressure is. One thing we didn't talk about is this device over here. This is actually a temperature relief valve, and that is if somebody happened to run it too fast for a long period of time and there was no output coming out of the nozzles, it would dump some water set at 145 degrees, because the pump would go into a total bypass mode. And that bypass would eventually heat up the water. You don't want it to hurt anything, hurt any of the bearings, or cause the water to boil, because it eventually would. And so this would dump the water at 145 degrees, bring in some fresh, cooler water, and it would just do it all over again. Help not destroy the pump. So I guess that's it. Hope you found this educational, and I'll go on to the next system. Well, what I could say about the next system is it will be the same one, but I'll be putting in a controller that will make it network capable. You'll be able to get at it over the internet, and you'll be able to change the cycling of it online and put in scheduling. And send alarms to the out on the internet, and pretty much you'll all be in the same package here. So that'll be it. I'll put that together and do another video.